Oh, all right. Got a interesting resolution here, but yeah, my name is Moyukh Sun. I work in blockchain security testing and engineering, some development work as well for secureware. And a lot of our clients primarily are companies launching new networks. So we see a whole range of consensus mechanisms, old and new, and help them with security testing and security code audits. One of our clients is POA Network, which is a project ran by Igor Baranov, who was one of the organizers of the Silicon Valley Ethereum meetup with Chris. Well, maybe he left, he was right there. And he's out in Europe now. But cool thing they're working on that is HoneyBadger BFT, and they probably have the most sophisticated implementation in Rust right now. And also from this morning, they also have a Rust implementation of verifiable delay functions, as we all learned about. So just to keep this lightning, I spun up a VM. And so they got, any Rust devs in here? No? Well, if you guys are in Rust stations, you should consider it. That's the thing that we advocate best. But so they, if you need Rust implementations of VDF functions, these work, which is cool. They got a set of CLI tools here. I did get that to work. You could also verify it with the same set. And that's cool. And obviously, if we mess with it, it doesn't work. They also have a cool benchmarking tool for VDF functions. And this is a 4 gig VM with 80 gigs of hard drive space. And let's see how long that'll take to run. It's been kind of fun to play around with. So while that runs, we can go over HoneyBadger a little bit. So
both a proof of space and a VDF.
Yeah, and I unfortunately they also have a pretty cool HoneyBadger demo. I wasn't able to get it to work. I think because of some networking config that I couldn't get last minute. Obviously, just throwing this together, so not even really a talk. But what's cool about HoneyBadger, it's not new. It's work from a paper by Andrew Miller at the University of Illinois from 2016. So there's a lot of talks and a lot of stuff out there. If you guys should check it out. But what we talked about this morning with leader election, security challenge with leader election is if you're able to compromise the leader, you could halt the network. HoneyBadger doesn't have leader elections. So that makes it very strong in adversarial network conditions. It also is BFT, unlike a lot of PBFT networks that we deal with. I mean, we've seen a lot of POA networks, Tendermint, Tendermint's BFT, a lot of POW stuff. A lot of the POS networks are delegated proof of stake. So if you look at things like EOS or Tron, they have a lot of like gambling apps on them. They're not that big, but you know, certain governments might not like that sort of stuff and could potentially attack known validators or de-anonymize them fairly easily because they have a limited validator set. What HoneyBadger, as you know, different people working on it keep building it, would let you do something cool since it's asynchronous. Like the timing of when transactions come in doesn't really matter. You could actually like do something pretty cool, like run your validator nodes behind like the Tor network, which is obviously unreliable in its availability properties, but would give you some added anonymity and privacy strengths as a network participant. And so even though you may not be able to guarantee the timing performance, HoneyBadger would still be able to validate transactions. And it does it by batching transactions through different epochs. and you guys can read over that. But this implementation, so the initial Rust implementation was started by Robert Habermeyer at Parity, and then he's doing all sorts of other Polkadot work. But this implementation is complete, and so I know some people already mentioned some interest, and so if you guys are interested in utilizing HoneyBadger BFT for any of your projects or networks, check out. Let's see if this thing finished. So check out their GitHub, and this is the demo is HoneyBadger, and got some cool other stuff with XDAI, which is a sidechain to MakerDAO. But the main stuff here, the security audits were just completed, and the implementation is complete. Now they're working on a delegated proof of stake type of system. But because it's in Rust, it should be able to participate in the Polkadot network whenever that is kind of launched. It shouldn't take too long. And they also have a good series of walkthroughs around how HoneyBadger BFT works and the way they implemented it on their Medium. So check that out and grab the Rust implementation, and you guys should start using Rust. And try it out into your projects. And if you run it locally, you won't run into the VM problems I'm having. Cool.
Great.